Testing 1, 2. Okay. So I was looking at this circuit here, and I'm thinking of a solid state way to operate this as a generator. If you take the first coil here on the right, this one here, and you don't have a diode here, you leave it open, a closed channel here, you'll have a plus 12 from this battery hitting this side of the coil, and a plus 12 from this battery hitting this side of the coil at all times. But when the gate closes here, right here, and you have this channel is closed now, this 12 volts will flow through here to the negative and meet the negative of the same battery that the positive came out of and give it charge. And when the gate opens, this particular coil here will fly it back. Regardless, it'll fly back this way into this battery, and the negative will fly back across the battery just like it does in the forced charge system. As you see here, this is the forced charge Bedini circuit. So the negative flyback will go, this direction through this battery. When this coil flies back, the negative will go this way, across this battery, through the ground, back up the ground to here, and it'll hit this negative terminal of the battery, this negative here. This negative will reach across this battery up the ground to this negative side of this battery. Negative flyback smacks this negative of this battery. Positive flyback smacks this side of the battery. Now the reason why Bedini had a high voltage diode is to keep to make sure that it goes into the battery. But quite frankly, he had the high voltage diode here because before, let me clarify this. The reason he had the high voltage diode here before is because before the circuit was like this, connected here. And when it's connected like that, this is, not here. And yeah, I mean, that's how it is without the forced charge. The regular Bedini circuit's just like that, It's not going through ground. Instead, it's just right there. And the negative of the charge battery connects to the positive of the run. And that's why you need the diode here in this scenario, because without this diode here, the charge battery will always excite this coil without the diode there. When this channel is here, that is, right, that's when it will complete the circuit 24 hours a day, if there's no diode here. If this diode is not there, and you have the circuit as it is now, this will be a 24-hour charge on this coil. This coil will receive 24-hour charge. You don't want that. So the diode is there. But when you remove this line here, that channel, and it's more like this, then this battery, will no longer give this coil 24-hour charge in this type of wiring. Because for one, assuming there's no diode here, for one, this positive will just, hit this coil, the side of the coil here, and reach across to another positive. And for this negative, or let's say for this positive here, of course it can get to this section, right? You can touch this part of the coil right there. You got a positive. But this is a charge battery, by the way. So this negative, you don't want it to touch the other side of this coil. If it does, it will give it full charge. The only way this negative gets to here is through this other battery in this force charge diagram, which is not such a bad proposition to have that happen. The worst that can happen here in this setup with this one coil without this diode on it, the worst that can happen is you'll have flow going from get this straight. You would have flow going this direction, positive charge from the primary. You would have, this is the only charge that this coil can get, and the only path it has to charge, and it would go this way through the coil. There's no diode here, so nothing's stopping it. But this is a positive now. Okay, it's got to reach this negative, it's got to go through the battery, through the ground, and back up the ground. In the course of this positive reaching this negative, it's got to go through a 30 ohm inductor. It's got to go through, I don't know, whatever impedance the battery has, a voltage drop across the diode. And by the time all that happens, this 12 volts is going to drop down to like, I don't know, a couple volts if you're lucky. And what's going to happen here is this coil will be primed all the time by that flow through this channel, through the battery, through the diode, positive flow, positive, through the 30 ohm coil, 12 volts now, not high voltage, 12 volts, low voltage. Not much is going to get through all this. You'd be lucky to get a couple volts go through all this ground and then back up to the other negative where it meets. By that time, I don't know, you probably have a couple milliamps running through this coil all the time. But those couple of milliamps will be priming this coil all the time, so that it's, if you have all these coils wrapped around the same core here, all the coils will be primed through that core. And when the trigger closes, when the gate closes here, of course, it's primed with a couple milliamps and a few volts of positive flow from the primary in this direction to the charge battery, through the diode, through the ground, back up the ground to the negative of the primary battery, thereby completing the circuit through the inductor to give it that couple milliamps and a few volts priming, and then the gate closes, and now all of a sudden there's a clear path to ground, a much clearer path to ground than through this other battery, and a much clearer path to this ground, to the negative. This positive now, when the gate closes here, this positive has a much clearer path to go through the gate. There's less resistance there, instead of going this way through the battery and the diode. They'd much rather go to the ground and back up here. And that's during the forward charge. So during the forward charge, we'll find it's a much easier path, and the priming part will end because it found the same current coming out of the primary battery that was priming this coil with a few milliamps, because it had to go through all that other battery and other diode. And keep in mind, this is 12 volts trying to push through here. Okay, and it has to push through a coil that's in series with a battery, and then in that battery is in series with a diode, and then the ground is in series to the negative of the same battery. So this positive has to meet this negative through this coil in that fashion, and it does so without the diode here. It will do that continuously, 24 hours. If you put the diode here, it puts a stop to all that. So if you have the couple milliamps and let's say 2 volts priming this coil here 24 hours a day, or during the power up cycle of the device, it's going to start switching, right? So a couple milliamps will be switched essentially off, but the coil will be already primed, and as soon as you close this gate, the couple of milliamps that were coming out of here before will no longer take this path. Instead, it will take this path. Excuse me, what am I doing here? Yeah, it'll take this path to ground. Much easier for it, and it will do that when the gate closes here. When the gate opens, this plus becomes a minus, and this becomes a plus now during the polarity flip. And this plus will go down here. It'll cut across into the charge battery, out the negative, through the diode, through the ground, back up the ground, to this negative. So that's where that plus will go when it flies back, without a diode on there. The only reason he had the diode before is because he had the circuit like this, and that diode was preventing this battery, the charge battery, it was preventing the charge battery from charging this coil all the time. That's the only reason he actually needed a diode. When it's wired like this, you don't need a diode, because there is no connection here to put a negative here and a positive there. This positive and negative does not meet here from the charge battery when it's wired like this. When it's wired like this, though, when this channel is here, they do meet, and you're going to need that diode. But excuse me, in the force charge system, you don't, because That channel's not there anymore. And instead now you don't have a negative touching here. You just have a positive and another positive. Two positives on both ends of this coil. Now the only way this coil is going to get charged is either from the charge battery or the run battery. If the charge battery is positive, it has to go up this way through the coil. It will have to take this path. It'll have to go this way through the coil. And this is low voltage now, 12 volts. We'll have to cut across a 30 ohm impedance, and then another, I don't know how many ohms batteries have, but, and then across this, and then the ground, and you know, it's a positive now, so this diode will block it. So that puts a stop to any path going that way to charge the coil this way, and not going to happen because of this diode is blocking the path. So we can forget about that happening with the charge battery. And look at the run battery now. How does the positive get across? It has to go this way through the same 30 ohm coil, down this channel without a diode, through the positive of a charge battery, and to the negative side of it, out the negative, and of course positive can flow that way. Got a positive. This is a positive. So it can flow through this diode, into ground, back up ground. And now this positive can meet this negative. So, and it does it with a series circuit of a coil, a battery, and a diode. Coil, battery, diode. Series, in series, this positive has to pass through series circuit, through the battery, through the coil, through the battery, then the diode, then the ground, up the ground to the negative. And I think it can do that at a very small level, because it's 12 volts now. And if any gets through at all, it's going to be next to nothing. It's going to be such a small amount, it's only going to prime this coil. And if you got all four of these, this could be a solid state option. You got all four of these coils around one core, and you're priming this with a couple milliamps on the off cycle. When the gate's open, then the gate closes, and the priming stops because it has a better path to flow. I don't know, that's just an experimental idea for this forced charge system. It occurred to me that you can actually do this without a diode there. And once again, only because in the forced charge schematic, it doesn't have this connection here. Creating that loop that you don't want the charge battery, you know, feeding power to an inductor directly. But, so that's just another idea here for the forced charge system. The idea is to not use a diode on this channel for the purpose of, or even if you kept the diode there. If you kept the diode there, if you kept the diode there, I don't know. I just, you know, I don't think you need the diode. That's all I'm saying to capture the flyback. The diode was there to isolate the charge battery before, you know. And that's what the typical, your average, your standard Bedini SG circuit though, is wired like that, and like this, and this is not here. But this is the forced charge circuit, which changes things a bit. And I just don't see why you need the diode there. I mean, if you want to trap the high voltage in the battery, I guess you would use a diode there, you know. And the difference of not using the diode when the high voltage occurs here, plus occurs here, and the minus of high voltage. If anything, you know, of course that high voltage will have to hit the battery, with or without the diode. This battery's positive has no path to go out this way. Even if it went through the battery and through the ground and back up, because this diode here blocks the positive. So this battery's positive has no way to get through here. Even if it could get through the battery, the diode stops it. And the only time that this positive can get through this coil, through this battery, up the ground, is when this gate closes. Maybe it'll go up this way, but then again, you have a diode here. You know, and the only thing that it can hit is this section without the diode. And that would be, which one, when was that? That was the positive. Right, the negative of flyback here would go through the battery, through the ground, up the ground. And yeah, when it's flying back, the gate's open. So this is not even open. It's not even closed when that's happening. This negative flyback has no place to go here. It's open. This is open. So this negative flyback has to go through all this to the negative of the charge. Can't go through here. It's open. Now this positive can channel this way when the gate closes through a negative here, right? This positive can channel this way when the gate closes. But it can't go that way because of the diode. So it'll go down to the ground, up the ground, this negative. It'll go up through here. And it's got an easier path to go down this way when the gate's closed. Through the ground, back up to the ground to the negative of the primary battery. So technically speaking, when the gate's closed and the coil's not flying back, this positive can flow through the ground, up the ground, through the negative, to the positive terminal, up this way, and basically this positive will meet itself on this end and this end of the coil, thereby not meeting a negative and creating any charge. So I don't see an issue there either. I don't see this positive going up this channel when the gates close, mind you. I don't see the charge batteries positive doing anything in reference to its negative. because of course you got this diode here. But if this positive were to flow somewhere and hit this negative and short out the system, it would flow this way when the gate's closed. It can't go that way, but it can go to ground, back up to ground, to this negative, which again does not short out anything because it's the negative of a different battery. It's not the negative of the same battery. I'm talking about this positive right here. I'm not talking about that positive. So having this positive meet this negative on a different battery does not cause any issue. And it's still, this positive is going to keep looking for its negative. It may go to the up this way, continue on, looking for its negative, and it won't find it. It will only find its own positive here. So I don't see how this is having the circuit like this is going to create any shorts or issues of any kind. I'll just throw that out there for you guys to look at and give your opinions and thoughts on a solid state version like this. I'm thinking that this system, I've never tested it. This is just on paper, but I'm thinking this system will on the off cycle, the system will prime this one coil here without the diode. And if they're all wrapped around the same core, all 4 coils will get primed with a very small amount of current flow. Because again, you have a battery, a diode, and a coil all in series, creating a pretty high impedance or voltage drop. If there is a huge draw on this, being solid state and you're not spinning a wheel, you don't have to have all these coils the same, having the same resistance to them. You can mix up the impedances on these coils. And if you are getting too much draw on the priming coil, which is there to prime all 4 of them, then you can add more turns to it until you get the kind of current draw you're looking for. That's assuming that there is any current draw at all coming from this positive here to this negative. In this path, if there's any current draw at all through this path, it's going to be minimal. And whatever that minimal current flow is, being the forced charge system that Bedini created here, whatever that minimal priming force is, not only will it prime this coil, but it will prime the charge battery with that small amount of power. And it will prime the charge battery. So whatever you're losing out of here to prime this coil, it's going to have to flow through here to do it, which is going to put it in there. It's going to give that charge to that battery. So it's kind of like you're not losing anything as far as power goes. You're recycling it through the battery, using the battery as part of the circuit to give the battery charge, kind of like the Tesla one-wire system. So there you go. This would be a good idea for a solid state generator, where the primary coil is this one, the one without the diode, receiving a small amount of charge, priming all the other coils that are wrapped around the same core. For the moment when the gate closes, whatever priming current was going through here is now going to stop going the way it was going before, which was that way. And now whatever priming current that was going on when the gate was open here is going to go through. The priming current will stop. That other flow I just showed you will stop. And now the new flow will be established of a higher current, less resistance through the gate to ground, meeting the ground right here. There's a lot less to go through there. All it has to go through is this one coil. And then when it flies back, with or without the diode, you're still going to have a high voltage positive here and a high voltage negative here. And that high voltage positive, with or without the diode, is going to smack the positive terminal of the charge battery. And that high voltage negative, with or without the diode, will go through here, through the battery, giving it forced charge on the way through, coming back up. And because negative, whichever way it flows, I have no idea, but it gets, you know, negative can pass in yeah, this negative here is available to any positive that exists on this side of the diode. So in other words, this negative here can reach through here to this positive if it's needed. And it will be needed because here is the negative. There it is. That is the negative. It's traveling up here and it's trying to meet this negative. So that negative will be able to reach over to this negative through this diode. Or this negative will be able to reach over through this way, through the battery, to this negative. Complete the circuit with negative, positive, and negative. I'm sorry, positive and negative right here. See, negative, positive. So yeah, you're trying to basically place the flyback coil across the two terminals of this battery to give it charge. Leave your comments for this. This can, you know, operate solid state with or without a core. Yeah, you don't have to put a core on this either. Probably still drive the motor, drive a rotor with it, and go non-solid state. It would still work. Your coils would be prime. Your first, only one coil would be primed in that scenario without the core. No core, and you know you're only going to have one coil being primed here. And you can still change the windings on this one, because this same, I would say, put the trigger coil on this winding as well. Yeah, okay, that's it. That's all I can think of. I need some more input from someone else to debate this and show me some things here that may not work or why it wouldn't work. Either way, it's worth trying this circuit out. I don't see any huge issues here without the diode here. It's worth a try to see what happens. Maybe because you don't have this connected anymore, you don't need that diode. And maybe having it without the diode and without this channel here, it's even more efficient of a flyback. If you had this channel here without the diode and the flyback occurred, and first of all, without the diode here, this battery will be giving this coil charge all the time, and it won't be able to fly back. But that only happens when this channel is here. That's with the regular Bedini SG circuit, not with the forced charge circuit. things change with the force charge circuit. Circumstances change. Resistance values change in the circuit, allowing for the opportunity to experiment without a diode to see what the outcome would be. Have fun, guys. Over now.